I'll spend a couple minutes and review the three structures that I talked about in the last three sessions. Hopefully you spent some time and actually worked with them after the individual sessions. The first one was independent growth or decline, depending upon the way that the flow is altering the accumulation itself, so that whether it increases or decreases depends upon the flow in or out, though the flow is not dependent upon the quantity that has accumulated. Now, in the example that was provided, the growth was linear. It doesn't have to be linear. It depends upon the flow. If the flow itself is not linear, then the growth or the decline won't be linear. It's just the essence of it is that there is no feedback, positive or negative. The flow in the inflow or outflow, neither one are dependent upon the amount of stuff that there is. So as I indicated before, this is a linear depiction, a linear growth, simply because the flow itself, as it's defined for this particular example, is a constant. So it's a linear flow. The second structure is a balancing or goal-seeking structure, where the current state and the difference between that and the goal is responsible for the state change, which is intended to cause the current state to move in the direction of the goal. And there's typically some factor that's used to govern the amount of the gap that actually changes the current state from period to period. Now note that goal-seeking structures or balancing loops always have goals, and it's appropriate to identify what that goal is. So in this instance, it's the typical ballot goal-seeking structure where there's a goal. The current state migrates towards the goal as the state change decreases over time, and the seeking factor here is very, very small. The rate at which this changes over time is dependent upon the seeking factor and the gap. And note that the transition is a little choppy here, and in the next segment we'll talk about time settings so you'll understand why this happens and how to deal with it. The third structure was the reinforcing or exponential growth structure, where the flow is dependent upon the amount of the stock itself. Either the inflow or outflow is dependent upon the amount of the stock, and it's considered reinforcing feedback, though typically there is also some sort of a growth factor that figures into it. So it's called reinforcing or exponential growth, and it produces the characteristic exponential curve. And in this instance, the amount that's added is less than the actual accumulation, simply because the factor is less than 1. So this is, when you see this kind of a curve, you have a sense that it's some kind of an exponential growth structure that's operating to cause this. Now, if you did not work with these individual structures in the last three sections, I would encourage you to go to the resources segment of this particular lecture and access this model and work with these three structures. Go ahead and you can exit storytelling, and there are parameters here that you can set for the independent growth, balance seeking, and reinforcing structure. And when you set them, the current state, maybe this is, and the goal is 700, and the seeking factor is 0.05, and then for the reinforcing accumulation, that's this one. Oh no, the reinforcing, this for this one, it starts at 1, which is good, and the growth factor is probably, something small, not too big. And then the accumulation of stuff in this one up here is typically starting at 0, and you define the flow rate to be something. And then when you run it, oh, be sure you go ahead and open it. When you run the simulation, you'll end up with a graph that actually has 3 different graphs on it, so that you can look at the independent, the balancing, of the reinforcing. And I put them on separate graphs simply so that they wouldn't all be on top of each other. So hope you found this informative, and I'll see you in the next session. Bye.